We have been looking at enhancing the number hunt project from the YByte Python curriculum available at www.ybyte.in. In this video, we'll talk of an extremely interesting enhancement to this game, which is basically saying that, okay, let's convert this into a two-dimensional number hunt. Remember, the number hunt game works like, computer picks up a number and we got to guess that number. Let's imagine that instead of picking up one number, computer picks up two numbers, say both between 1 and 100, doesn't matter, it could be any range. But we view this as the x and y coordinates of a target. So it's like computer has got a target somewhere in the sky, somewhere in this, let's say in this region. We have to guess this target every time we make a guess. So again, we guess two numbers. We are told where our guess is related to this target. So we view this whole thing as though it's in some xy coordinates. In fact, the enhancement, the way this game plays out is really, really interesting. So in the single number case, for example, we were told if the chosen number was smaller or larger. Here we'll be told where the target is with respect to our case. We'll talk about this a little while, but let's just try building this in a step-by-step manner. The first question that comes up is, okay, look, my computer picks up two numbers, which means my player also must provide two inputs, say the x and y coordinates of the guess. So we could certainly do that by asking two questions. Okay, tell me the x coordinate, tell me the y coordinate. But that gets very repetitive and not very pleasant experience. So it's more efficient to in fact ask player to provide two numbers as an comma separated values. So let's do this first. We'll do this in a step-by-step manner. So let's see how we do this. So what we will do basically is we'll take the input, we'll split this into a list, right? So remember this input is going to be, let's say, some 100, say maybe 20 comma 50. So we're going to split this into list. That will be 20, 50, and we will extract out the x and y guesses from there. And let's see this working, because this is interesting. So I come in here, in my code, I'm selecting two numbers, say x0 and y0. Computer is picking these up and it tells that, okay, look, I'm hiding somewhere in the square region between 1, 1 and 100, 100. Can you find me? So like I said, while not done, and this is exactly what we were doing in the, one-dimensional case as well. We were asking for a guess, right? So here I'm going to ask for a guess. So let's say guess is, say, input. Remember, I'm not converting this to integer just yet because I want to get two numbers now, right? So I say guess my x and y coordinates, say coordinates, comma separated. So separated, and let's say \n. Now remember, this will be something like, say, 50 comma 20, something like that. Now we need to extract from this the x and y coordinates. So what I do is I convert this to a list. So I call it guess underscore l, and that is basically guess dot split with a comma. So what this does is wherever this in the strings finds a comma, it creates a new item in the list. And once I've done that, so guess L is a list, so I can just read off the two items. So I say guess X is equal to guess, for example, L, say 0, and guess Y would be guess L 1. However, notice if I did this, then both of these will end up being strings. That's going to cause me problems. So I'm going to convert this to an integer. So basically guess X and guess Y both become, let's say, so say int for guess X and guess Y. Now let's see this working. Obviously this is an infinite loop right now, but we will, we'll just try to understand what's going on. Let's say I give a value 12 comma 45. Now if I just did, say, control X, so I just did control C just to break it off right now. So if I look at, say, guess underscore L, that is a list because, remember I split this in 12 and 45 depending on the comma. And now if I see guess X, notice that's an integer. That's not a string because I converted to a string. I'm sorry, converted to an integer for the first element. And then similarly guess Y, that is the next integer. So 12 and 45. So in some sense, I've got my equivalent of the guess earlier. Now there are guess X and guess Y. And this is where the game has to really start. Now, once we have the guess, we really have to now figure out where is this guess with respect to the target. Remember, in the one-dimensional case, we just told, okay, if the guess is smaller or the guess is larger. But now it's a little bit more complicated because there are, in fact, many scenarios. For example, guess could be here, target is here, in which case the target is on the right side, higher than the guess. In this case, the X is the same, but target guess is higher. In this case, the target is on the left side, but higher. In this case, target is on the left side, but same. In fact, if you think through this carefully, you will find that there are exactly 9 scenarios. which have all been listed here. Now, this is for your reference. Take a look at this. Basically, I've identified the 9 scenarios. The first scenario is the one where both have become equal and the target has been located. Otherwise, I have like, x is same, y is less, and so on and so forth. Now, just to facilitate the understanding here, I have given you a diagram here. So what we are saying is case number one is when, target has been exactly guessed. Case number two is that I got the x value correct, but the y value is lower. Case number three is y value is higher, x value is correct, and so on and so forth. So really, pictorially, we know that there are exactly 9 cases, and what we are going to do is to code up all these 9 cases, right? And this is exactly actually quite similar to the earlier one-dimensional case, just that it's a little bit more involved because of all these cases, right? So let's do this one by one, very slowly, very deliberately. It's a little bit repetitive, so we'll do the first ones very carefully, and then remaining will just follow. So I'm going to say, look, if a guess x is equal to x naught, remember x naught is my actual coordinate. If this happens, then 3 scenarios come up. So I'll look at, if guess, say, y is less than y naught. If guess y is less than y naught, so I just go and say, look, print, I put a print statement. I say same x, but my y is higher. Now remember, guess y is what I'm guessing, y naught is actual y coordinate. So target tells me, look, my y is higher, just like I told my number is larger or my number is smaller. On the other hand, if I have, let's say, if guess, y is greater than y naught, well, very similar. I just take the statement and copy it around. So Control C and say Control V here. But this time round, I'll say my y is, say, lower. And I'm going to put a backslash n on all this so that it kind of behaves well. Finally, if my guess, guess y is equal to, say, y naught, now it means that in fact I've done the job. So I'm just, I've met the target. I just go and say, look, so bingo, I'll just say bingo, you caught me, let's say. And so I can put backslash n. I can just count, let's say, how many attempts I took. Say print, say attempts equals to, and I can put a comma, let's say here, and say attempts, exactly what we were doing earlier, just little bit different from let's say the presentation is a bit different. Most importantly, I must set done to true, because otherwise I have an infinite loop, and that is a problem, right? So basically I've covered the most important cases here. Now exactly same thing is going to repeat as I look at the other scenarios. So let me just copy this whole piece of code around and paste it. I have to be a little bit careful for the indentation. So I have to just make sure that the first level indentation is all matching, then everything is indented from there, right? So I say, okay, if guess x is, let's say, less than x naught, so if guess x is, say, less than x naught, then again 3 scenarios arise. So here so it's a both x and both x and y, say, are higher. If y is more than let's say y naught, so basically situation is x is higher, my x is higher, but my y is lower, because again y is guess is more than y. And if guess y is, let's say, equal to y naught, in that case essentially I have a situation where my x is higher. So it can't be this. I'm just going to say, well, my x is higher, uh, my y is the same, my y is the same. Now again, do this slowly, do this carefully. It's very logical. Okay, so I've got to put a comma over here, right? Now having done this, the third set of conditions will follow from here. So I just take this again and I copy this once again here. Now notice again the indentation is important. So I'm going to look at the third scenario where x is greater than x naught. Now if this situation happens, well, both, in this case basically my x is lower, so I say my x is lower, my y is higher, right? So my y is higher. In this case both x and y are lower, so both, so what did I say, both x and y are lower. Okay, so and the final one is my x is lower, just reversed from here, so I say x is lower, my y is the same because y is equal to y naught. Now, really, this is all we need. Of course, we need to increase the attempts over here. I think I've done that already, right? So attempts, okay. So every time I do this, just like earlier, I'll say attempts is equal to attempts, say, plus 1. Now, really, all we need is this. Now we can, win this game, or let's say play this game. Now, really, if we knew the direction, so if we knew, let's say, some the target is in a certain direction, then we could change x and y in a certain ratio to go along the direction. For example, if we knew that my x naught was equal to y naught, I could go in a 45-degree line and meet my target. But given that we do not know, it looks like the optimal strategy is just to do binary search on both x and y axis. And the best part is we can do it together, makes it really interesting. So here I go, I just run this code. It says, okay, look, I'm hidden somewhere, find out, where I am, because it could be 1 and 100. So I try, let's say 50, 50 for both, right? So 50 on x, 50 on y. It tells me both x and y are lower, which means that I have to go, his x and y both are lower. So I'll try, say 25, 25. My x is higher, but my y is lower. So I'll try, say 37, say 12. So I'm just doing a binary search type of thing here. Both x and y are higher. So which means that I've gone too low in the y. So I'm going to say, let's try for x. Maybe x is between, 37 and 50. So I'll try, say 43. And for y, I'll try, let's say something like 18. So it says both x and y are higher. So I'll go further. I'll say 47 perhaps and say 21 maybe. It says both x and y is still higher. So let's try, we are between 49 and 50. So I'll say 49 and say 23. My x is lower, y is the same. So notice now a conversion on the y. My x is lower. So, well, I have not much choice left. I'm going to do 48 and 23. And I have found it, right? So it's pretty amazing how we did binary search on both. There's some extra prints coming from somewhere. We have to see. Okay, because these two. Now, if I move the sprints backwards, then the game will appear a little bit more compact. Now, I hope you found this interesting. This is actually really, really cool because you can really kind of visualize moving through certain path till you reach that, let's say that target, right? Um, in general, if you find that this way of learning Python is interesting, do look at our website because we have many, many, many such activities. We build them, we think about them, we enhance them, and we learn a lot from them. Take care. Thank you so much. Bye bye.